Hello, I'm Tom Smith and I'm the Managing Director of Thermofluidics.
And I'm Christos Markidis, the Technical Director. Thermofluidics is developing a thermally powered pump based on a principle that we call the non-inertive feedback thermofluidic engine, or NIFTE. In this video we're going to demonstrate the NIFTE pump in a real-life application. We have chosen that of a circulator pump in a domestic hot water system. For this purpose we have attached a NIFTE pump to a wall-hung gas-fired condensing boiler. The NIFTE pump consists of three main parts: the power cylinder that would normally be wrapped in insulation, the cold heat exchanger that's wrapped around the power cylinder, and a hot heat exchanger that is at this moment embedded inside the primary heat exchanger of the boiler. As soon as the burner is switched on, the working fluid, which in this case is water, in fact the same water that is being circulated to the radiators, evaporates. And when it evaporates, the pump is set in motion.
You can see now that within seconds of the boiler firing, the oscillation has commenced. The liquid level in the NIFTE pump moves up and down, and via non-return valves it's coupled into the water system and pumps water around it. At the moment, the boiler is modulating so that it's firing very little gas. Shortly, now, you'll see that the boiler modulates up, the flame grows, and the NIFTE pump very quickly responds and pumps a greater flow rate of water. You can see that the liquid level inside the NIFTE pump is moving up and down in this transparent column here. We've cut away the insulation and we've used transparent tubing so that you can see the oscillation. Note that the NIFTE pump is virtually soundless. In fact, the only sound I can hear right now is that of the burner. This is our water test system, which represents the radiators and the household into which the boiler and eventually the NIFTE will be installed. Down here is a tube containing an oscillating flow generated by the NIFTE. Up here are two pressure reservoirs, or accumulators, which behave very much like the expansion vessel would in an existing system. On the right here is the low pressure reservoir from which the NIFTE sucks water, and on the left is the high pressure reservoir to which the NIFTE discharges water. The resulting pressure difference drives an approximately steady flow through the rest of the system, which represents the household full of radiators. And we can change these valves here to simulate different households and different flow conditions. If we look at the level of the liquid inside these reservoirs, we can see that the magnitude of the oscillation due to the NIFTE is very small. This serves as some indication that any disruption to existing components, such as the expansion vessel, is likely to be small. We've now decoupled the NIFTE pump from the water system and connected it up to a bucket via a series of hoses, so you can get an approximate idea of the flow rate that it is currently able to deliver. I've now switched the boiler off, and as soon as I do this, the heat source for the NIFTE pump disappears and it stops oscillating. you can see that the liquid level inside the pump is now moving up back to its cold position.